Alright, let's tackle activation function. We'll use this a lot. Yeah. So here I describe the multi-layer perceptron. You know, this we call a multi-layer perceptron with a hidden layer H. I've shown that the hidden layer by itself does not create a non-linearity. So basically what we need to do is that we need to have the output of the hidden layer pass through an activation function. It's the activation function that will give you the non-linearity. Yeah? These are the activation functions. So let's take a look at a few activation functions. And basically these three that I wrote here are the ones we're going to use the most. Yeah. First function is sigmoid function. And so the activation function on H1 actually is 1 divided by 1 plus e to the power of minus H1. So this gives the non-linearity. We've seen this function when we discussed the confusion matrix. Remember, we had a curve that looked like this. Yeah. So we could basically here we have a linear score. Remember that was the weight of certain people. And this is 0, so you pick any weight of a person, you will translate to a probability. Yeah, so sigmoid converts a linear score to a probability, and it's used for binary classification. And we define the threshold. So this person here, because it's above the threshold, this person would be classified as obese. Probability. So let's say the probability that the person is obese is 75% in this case. Yeah, so we're gonna classify as obese if your threshold is in the middle. We've also seen that we can decide to change the threshold. This is to increase or decrease false positives and false negatives. Okay, so that's it for sigmoid.